Anyway, talk about Bluetooth. Just a quick little kind of history. Ericsson invented it in 1994. It's been around for 20 years, over 20 years. And it's designed to be a wireless communication digital. So we talk about analog and digital. So this is, Bluetooth is digital. And it's like Wi-Fi. The current version is 4.2. However, what we deal with in audio is the same since 2.1. That has not changed. The truth of the matter is Bluetooth is not designed for high quality audio. It's designed to be low power and low data transfer rates. So the whole range of profiles for different applications. There's a lot more. Yeah, so besides these, there's 20 or even more of different profiles. The ones we care about, A2DP, and this is the advanced audio distribution profile. That's the highest quality audio profile that's available in Bluetooth. This is an audio video remote control, AVRCP, up and down, volume up, volume down, remote. HFP and HSP. These two are really low quality audio, but for your Bluetooth headsets. So really, these are the four profiles we care about for Bluetooth. So, service discovery. This profile is supported by the BTC. And we're talking about the BTC 4148. It's a Bluetooth interface, this device right here. It's made by Portland Tool and Die, and Listen is the only distributor for it. So it works seamlessly with SoundCheck. It recognizes it as a part of Listen hardware, and automatically sets it up within SoundCheck. And it shows up in your computer as a audio interface. So it doesn't even know that it's really talking to a Bluetooth interface. It only sees it as an audio interface. And the profiles that the 4148 supports is service discovery. And that's nothing to do with audio, but more a way for Bluetooth to talk to each other. We talk about A2DP. This is the high quality audio transmission like Bluetooth speakers. It allows the frequency response goes up to 20K, whereas if you're talking about the HFP, HSP, it only goes up to 8,000 hertz for your frequency response. And here's the other one that it supports is a remote control, play, pause, forward, backwards, volume up and down. So it's not really audio related, but it's sort of controls for audio. So these two, HFP, A2DP, are really the ones that we care about the most. So a little bit about what happens when you try to get Bluetooth to pair with each other or connect. There's a step-by-step kind of process here. First step is what they call inquiry. So I'm in a room full of a lot of people that I don't know. I want to make a connection to someone. Essentially, you basically go in there, discover who you can connect to, and then exchange information through the service discovery protocol, the profile, service discovery profile. So first step is basically I'm going to the room and say, hey, I'm here. Who else is a Bluetooth device? Can I talk to you? So you gotta gather the information on whoever is around, and then you decide who you want to talk to, who you want to be friends with. Once you determine that, the devices will exchange a link key, it's an encryption key, that just says, okay, now I only want to talk to you and no one else, And whatever we talk about is a secret. No one else can get in on the conversation. And then it's going to open, based on that, the different profiles for audio, whether it's A2DP, if it's the remote control, or HFP, HSP. Now, you don't have to do the first step if you know each other's Bluetooth address. So each Bluetooth device has a unique address. And if you know that already ahead of time, for example, in a production line, you don't have to do the inquiry, which is the first step. You go straight to the second step. Because the first step takes a long time. You kind of have to ask, and then when you ask, you have to hear back, and then you decide what to do. If you know the address, you skip right to exchanging the link key. And if it's already paired, you can straight to opening the profile that you want to run. Keywords. A2DP stands for Advanced Audio Distribution Profile. It supports up to 48K audio in one direction. This is remote control. And the HSP, HFP is for the lower quality audio profile. Now within each profile, there's different codecs. A2DP has SBC and aptX, and it can produce what they call a full scale dB, 0 dB full scale. So it has relatively the best audio performance for Bluetooth. On the other hand, if you're talking about HFP, the codecs are CVSD and MSBC. These cannot produce 0 dB full scale. You cannot get there with these profiles. And they do have idle tones and very high noise, so poor audio quality with these profiles. HFP, HSD, these codecs, CVSD and MSBC. So if you look at the behavior of the codecs, this is the A2DP profile, and the green line is the SBC codec, and the yellow line is the aptX. You can see that here's a 1 kilohertz tone, a sine signal. The SBC codec has a lower noise floor than the aptX, but it's got all these kind of distortion products out here in the higher frequencies. Whereas the aptX has a higher noise floor than the SBC, but it doesn't have the same problem in higher frequency. So it's just a different behavior based on the codec. And we talked about the HFP profile. If you look at the CVSD codec and you try to get to 0 dB FS, you get all this distortion. And also, there's an idle tone here. It's always there when there's no signal. So two things here. The CVSD can't get to 0 dBFS full scale, and there's an idle tone when there's no signal. So, in the BTC, to deal with those problems, we'll have the signal always at minus 10 dBFS. So we don't want to go to the full scale. And we can inject a idle tone suppression signal. So we inject a low level signal into the codec, the idle tone disappears. And that's built into the BTC automatically. So you don't see the behavior like the last slide. So there you go. Here is the example of the output with the HFP profile. Here's your idle tone. And once we inject the suppression, noise suppression, the tone suppression signal, you get a much better response. And that's a built-in suppressor inside the BTC. And there are two versions, actually, I should say. The BTC is this one you see here, which has a touch panel in the front and allows you to switch profiles. You can do that manually from the front panel. And then the other version is the BQC, which is a production, designed for the production line. The BTC 4148 supports A2DP, HFP audio profile. So the BTC 4148 supports A2DP, HFP, HSP profiles. Also the different codecs, SBC, APTX, CVSD narrowband. It also comes with the idle tone suppressor built in, and MSBC for the wideband. And the interface, you can do it through USB in the back or SPDIF if you have a digital connection. And this one has a touch screen, or USB through SoundCheck directly. And there's also a connection in the front if you want to have a direct connection to the antenna. You can do that. This is the smaller version. It's about the size of the speaker right here, approximately. It's just designed specifically for production. And it's also source only, which is most of the cases you're going to do in production line testing is having a source only connection. Again, interface through USB, no SPDIF on this one. And there's the antenna, which is you can have an antenna or you can have a direct connection. Yeah, so quick summary. Touchscreen USB for the 4148, USB only for the BQC. And I think we reviewed this already. All right, so I'll show you a demo of the Bluetooth. Okay, so just very quickly, this nice feature in SoundCheck 14 that just came out recently, which allows us to identify all the listen hardware automatically. So it says, I know I have a BTC connected, and I know everything about it, the serial number, and I know how to set up a startup default for that particular instrument or device. And what it does is it would go here and set up your hardware. For BTC is not so special because the VP it's digital, so it's one. But say some other things, analog devices, then you need to understand the VP. So anyway, that's not really what we're looking at here, but just want to show you that the BTC can be automatically detected and set up by SoundCheck. So here's a little quick sample sequence. it basically showcases the ability of the BTC in one sequence. What it will do is basically test the speakers in the Bluetooth speaker here. It's just it's a Jawbone Jambox. It's a pretty nice speaker. One thing nice about this one is it allows you to, it tells you it's in pairing mode. So you know it's ready. And it has a microphone built in as well. So what this sequence allows us to do is, first, I guess I could explain what happens, but it's going to play an idle tone to make sure that Soundcheck knows it's ready to be tested. And then it's going to do a sweep, first in the A2DP profile, and you'll hear it. The quality of sound is pretty good. Then switch to a different profile in the same sequence. Now, some other Bluetooth devices or Bluetooth interface cannot easily do that, but the BTC can easily switch profiles. And inside the sequence, again, it's going to play a test tone to make sure it knows it's ready, do a sweep, and then actually change to the microphone. So it's going to play a signal out of the source speaker and then test the microphone. So everything is in the same sequence. And you can see the results. Well, I'll run it, but it gives you the frequency response, A2DP, HFP, THD of A2DP and HFP profile, and then finally the microphone response inside. So let's do it. So it says, turn on the device, make sure it's in pairing mode, which this thing allows me to do.
Mini Jambox is in pairing mode, waiting to pair with your device.
It's very nice, tells me it's ready. So right now, because I didn't tell it to go to a specific Bluetooth address, it's looking for it. It's doing an inquiry to everybody in the room saying, where are the Bluetooth devices are there? And it will show up the list right here when it's figured it out. But you can tell it's taking a while because the inquiry process is the longest process. Now it sees all these things. And like I said, if you know the address, if you already know the address, say in production line, you know your Bluetooth address, you can automatically put the Bluetooth address in and connect. It saves a lot of time in the process. So I know my device is the Jawbone Mini Jambox. Do OK. And you can see it running here.
Mini Jambox paired.
It's right here now. It says connected. Now it's going to play a tone to make sure that's see the step by step. Now it's playing the stimulus. And because we have different sampling rates, here's my resample step, and here's my frequency shift step. And then I'm going to do the analysis, just like all the other testing that I would do. And there's my response based on A2DP profile. Now you can hear it's not as good now because it's switched to HFP. Same steps. Again, resample, frequency shift, analysis. Oh, same problem. We had a bit of an issue before, but the final step would have been to play back a stimulus on the source speaker, and then the microphone will pick up the response through the BTC and does analysis, and I'll show you the graph, I guess. That's a bit of cheating, but there would be a response here from the microphone if it was working properly. But you can see the response here. It's, the green line for A2DP is the full 20 to 20K, and the HFP is much worse, 100 to maybe 7K or 3 maybe 3,500. And here's the THD. So the BTC can do all that in the same sequence, switch profile, no problems.